Assalamualaikum. Hi, my name is Nurul Elmia Farhana binti Mutaha. For my presentation, I'm going to share with you one of the sustainable material for construction, which is bio-bricks. Okay, so first we will go through for the
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatimah binti Ishaq. I'm from J4EC110.1 and my number ID 2019239258. So I would like to share with you guys about environmental friendly durable concrete, which is the sustainable concrete is made by using recycled materials.
Hi, Assalamualaikum. My name is Nur Asma Miza binti Zalani with metric number of 2019, 264 and 142. The article that I choose for this assignment sustainable product is the recycled concrete and mixed rubber as aggregate for these sustainable products.
So this is the table contents. We have introduction, method, finding or result, discussion, conclusion, critique and reference.
introductions of the articles, or known as the purpose of the aim for the research or study is done. Okay, so first, construction is known as one of the largest industry in the world. Due to fast urbanization and population increase, there is a tremendous demand for housing and other housing-related services, which resulting in a lack of traditional building materials. Here, okay, so traditional building materials use a lot of energy and contaminate the air, water, and land in the process of making such. As a result, new sustainable materials are required to meet the ever-increasing demand for building materials. So the primary goal of the study discussed in the article is to develop a method for converting solid agricultural waste into usable building materials, which is bricks. Current research investigates the use of agro waste, such as straw stubble, rice paddy waste, unused wood, and so on, as an ingredient in the alternative sustainable bricks named bio-bricks. Okay, so by use of agro waste as a construction material has the potential to reduce the natural resource consumption as well as energy usage. Okay, so here we can say that all the traditional method or traditional materials, which is bricks or concrete, will consume a lot of energy, and it by this it will increase the demand, so we need another products to replace or to as an alternative to reduce all the energy consumption and also the materials needed for the all traditional material used in the construction. Okay, so next.
Okay, for the introduction, generally, concrete always used in construction industry as materials, which is as the main material for building. Unfortunately, the Portland cement, the materials that mix together with other materials to make a concrete release carbon dioxide and greenhouse gas emission. From that, the issue of environmental always talked about by the community. Therefore, world need a uses of sustainable material so that if it can reduce the environment problem and produce an environmental friendly, durable or greener concrete. To make a greener concrete, we must use the reuse post-consumer waste and industrial byproduct. Greener concrete can improving the air quality, minimizing solid waste, and lead to sustainable cement and concrete industry. Example, the materials that can be added in concrete mixture is wood ash, spun dry sand and slag, blended cement, post-consumer glass, and pulp and paper mill residual solids can reduce, which is can reduce the uses of manufacturing cement and makes the concrete more durable.
The introduction of this article is the recycling of concrete, bricks, and also the necessary rubble as concrete aggregate is an important way to contribute to a sustainable material flow. The fluctuations in the composition of recycled aggregates, the reinforced concrete structure made with recycled concrete are to have differential behavior rather than those made with conventional concrete. In addition, two beams with a high percentage of poor recycled concrete aggregate and mixed rubble aggregates were casted. Thus, the beams were casted up to their ultimate shear load resistance considering the facts that mechanisms influencing shear strength such as aggregate interlock, bond, concrete tensile strength are most affected by the concrete performance than flexural strength. The use of this material as aggregate are important in order to protect our environment and also the animals to live in this world. Next, the method used in this article is
Here is the BioBricks application. So we know that as BioBricks is more better than um, burnt clay bricks since it will produce low energy consumption and it is more efficiently and more sustainable. So here is the application for the BioBricks. Okay, so but in this case, BioBricks cannot be directly applied in the load-bearing structure. So for the first one is insulation material for corrugated sheet roofing. So the BioBricks panel can insulate home from external heat. Secondly is the filler wall material for column beam structure. So we know that the BioBrick is low in density, so it will give light weight to reduce all the overall structure for the beam and the column. So next is low cost bearing housing. So it is suitable for to build a low cost bearing housing. So it will maintain the humidity in the house since it is suitable for the construction of house at a country that has hot temperature or low in humidity, and the application of biobricks is suitable and perfectly efficient for the house since it will keep or will maintain the humidity in the house. Next is the biobricks production or the procedures of making the manufacturing the biobricks. So first is the selection, which is we need to careful selection of the dry agro waste, which is then chopped with desired sizes. Here is the first procedure. Second one is preparation. So a lime-based slurry is prepared by adding slaked lime, binder, stone dust, and water. So here is the another mixture to be added into the biobricks production. Next is mixing. From the first steps and to second step, we will go into the mixing step, which is the chopped agro waste here is added to the slurry and mixed thoroughly by hand or mechanical mixer to produce a homogeneous mixture. So the step 1 and step 2 will be combined here for the step 3. For the mechanical mixer is used for the large production of the biobricks. If not, they will just use the hand mixing. So next is compaction. The mixture is poured into molds and rammed with wooden block to make a compact brick by removing the air, voids, and extra water. So the last one is this mold are left dry for a few days, about 1 to 2 days, and then the brick is allowed to dry for 15 to 20 days. Actually, the biobricks will take about 1 month to reach its strength by air drying method. Next is the prototyping or the procedure. Here I'm attaching the picture of the procedure for the making of the biobricks. So here is the chopping or the selection, and then the material will be chopped into the desired sizes, and then this is the preparation of other mixture, and is the mixing procedure or mixing steps, and then it will be compacted into a mold, and here is the products after 15 to 20 days of drying.
So next is the method of for each material is produced. So for the wood ash, it's produced by generating the combustion of wood, bark, and scrap. It also composed by organic and inorganic materials. When the combustion temperature increases, the yield of wood is decreased. So next is blended cement. It produced by intergrinding of clinker with one or more additive. The production can reducing the energy uses and reducing the greenhouse gas and carbon dioxide emissions. So next, pulp and paper mill residual solids. It produced by composing the cellulose, fiber, clay, ash-bearing compounds, chemical and moisture. It can reduce chloride-ion concrete penetrability and enhancing salt scaling and freezing and thawing concrete resistance. So next is post-consumer glass. It produced by crushing the glass where it can control alkali silica reaction. It also produced by glass reinforced plastic, or the short form is GRP, but it helps in conferring lightness and ductility. So next is palm dry byproduct, which we have two materials or product, which is sand and slag. Actually, it's produced by using the core to make a shape in sand mold, where the molten will pour into the mold. The silica sand is the main core, where it has a small percentage of organic and inorganic binder. So, palm dry sand, it will replace the regular sand, but it can reduce the strength due to the water increase demand. It also can replace the fine aggregate in hot mix asphalt, or short form is HMA. In control low strength material CLSM slurry, the palm dry sand can give favorable environmental performance. So for palm dry slag, it used as a coarse semi-lightweight aggregate in cement-based materials. It also can replace the aggregate in manufacturing the structural grade concrete.
First of all, the shear resistance test, which is this method, is used by tested three large-scale T-beams, and the beams were made from aggregate, recycled aggregate 5 mm, recycled aggregate 6 mm, and primary natural aggregate, and will be referred to as beam RC5, RC6, and conventional concrete CC. RC5 is the recycled concrete 5 mm, recycled concrete 6 mm, and the conventional concrete CC. The midspan deflection were measured by an inductive displacement transducer K3. Strain gauge measure the concrete strain on the top side of the beam K5 until K7. The strain in the stirrups K8 until K19, and in the flexural reinforcement K20 to K23. Load, deflection and strains were recorded electronically. The hydraulic jacks, each with a loading capacity of 1000 km, were controlled by a pressure gauge. This is the method used. The figure 1 shows the grain size distribution of mixture. Recycled aggregate 0 to 4 mm. As you can see here, the graph percentage spacing by weight versus grain size in millimeter. And also this is the figure 2 show the grain size distribution of mixture reinforced aggregate 5 to 8 millimeter. And this is the what I mentioned earlier, which is this is the K6, K5, K20, K21, 22, 23, K7s. And next is the method used is the water content. It's used by the heat drying a sample of fresh concrete until the mass becomes constant. It is used to evaluate the water cement ratio. The water absorption of the aggregate was taken into account. The total water cement ratio with respect to the water absorption is presented. And then the testing fresh concrete, which is the degree of compactability, which is the intended flow values were 350 until 480 mm and the intended compatibility is 1.04 until 1.25. Next is then the method that is in this article is the testing of fresh concrete, which is about content and wood density. The fresh concrete properties were measured at the plant immediately after production and in the laboratory after a transport time of approximately 30 minutes. Specimens used to measure the properties of the hardened concrete were made in the lab. And then the methods used is compressive strength, bending tensile strength, and E modulus. It be measured for the 120 mm times 120 mm times 360 mm concrete prism after curing at 20 degrees Celsius and 90% relative humidity for 28 days. Set values of each mixture were determined for compressive strength, 3 for tensile bending strength, and 3 for E modulus. Shrinkage and creep rate were also been determined at a temperature 20 degrees Celsius of and relative humidity of 70% onto prism during 91 days. Then the method used is the oxygen permeability and chloride conductivity, which is the recycled concrete of 5 to 8 mm were measured on cores taken from separately produced tubes with a diameter of 68 mm and a height of 25 mm and were measured per mixture. Then the oxygen permeability test. It was tested based on the degrees of the applied pressure gradient due to oxygen passing through the samples. The value for oxygen permeability are presented as negative decadic logarithmic values. The oxygen permeability index, which is OPI. And then we have reached for the result and the discussion.
Next is the results or data acquisition. Okay, so here is the result from the articles that shown the top wise waste generated and fraction burned in India. So here is the example of the agricultural waste in India. Okay, so first is rice paddy, wheat, maize, jute, cotton, groundnut, sugarcane, wrappers, and mustard, millets. Okay, so before the ideas come to produce the biobricks, all the waste is being disposed by burning, and of course the method will increase the greenhouse effect to the earth. So by applying or by using the new methods for producing the bio bricks, so we can reduce the pollution, and this waste will use for beneficial purpose, especially for the construction industry. Okay, so here we can see all the data: annual production, dry residue generated, residue to crop ratio, dry matter fraction, and also the fraction burn. So here I'm going to explain about the types of types of agricultural waste in India. Okay, so here just the example from the article. So next is, so for the discussion, I'm going to make a comparison between the traditional material, which is burnt clay bricks, and also the bio bricks. Okay, for first, bio brick as contrast to burnt clay bricks are not only more environmentally friendly, but these products also function as a carbon sink, absorbing more carbon dioxide than they emit over the course of their lives. For an instance, as shown in the prototype, where 900 grams of sugarcane bagasse was utilized to produce the bio brick. Meanwhile, by burning 1 kilogram of sugarcane bagasse, we release around 710 grams of carbon dioxide. As a result, during the life cycle of the biobricks block, the net greenhouse gas emission is approximately negative 1.015 kg carbon dioxide, indicating a net positive influence of the environment. So this means that by turning the waste into the biobricks will save and will more environmentally friendly instead of burning all the waste. So at the same time, agricultural waste can also utilize in a better way compared to incineration. Incineration means burning. Nevertheless, biobrick is not suitable for load-bearing structure construction due to its strength compared to the burnt clay bricks. However, biobricks can be used in walls since they provide good heat and sound insulation. These biobricks also help to retain humidity in buildings due to their porosity and low density, making them suited for hot, humid climates. Plus, biobricks has low density, so it is suitable for partition walls replacing the burnt clay bricks. So here, of course, I'm supporting or I'm agree with the idea of the bio bricks production to replace the burnt clay bricks, although they are not strong enough to build to be used in the large construction, but we can adjust the bio bricks ingredients or the mixture so that the strength can be improved or can be increased. Plus, the biobricks also bring benefits to all the farmers that just before this dispose their agricultural waste by burning or incineration. So they got nothing and no benefits from that methods of disposing. But when they are selling their waste for the to the factory that producing the biobricks, so they will gain income from them. So that is so proof that biobricks is so economical instead of help the farmer to gain more income. So next, the last one is about the
So next, we will look more about finding and result. So for the wood ash, the result that I get is the first physical property, which is this fly ash actually the part of wood ash. So the specific gravity it has 2.32 until 2.7, and the unique weight kilogram per meter cube we have 365 until 920, and for the cement activity index it have 49 until 90, and for the blended cement the things that I find is it can expand the production capacity, reduce carbon dioxide emissions, reduce the fuel consumption, plus monitoring as supplementary cementing materials CSMS quality. Okay, next is post-consumer. What I find is for the ground waste glass or waste glass, actually there's no there has no reaction with particle size 100 micrometer can be reused as fine aggregate and mechanical performance improved when it contribute with mortar microstructure properties. Next is mixed color glass utilized in self-compacting slurry or concrete, and also increasing the concrete impermeability as the age increase. So next is found dry slag. What I found is it can produce around 101 million tons of foundry byproducts, including slag. This product also is landfill. Okay, so next is pulp and paper mixed residual solid, which is I found the chemical properties and also the value. Okay, for the first is calcium oxide. We have 0.55 until 31.46. And second one is silicon dioxide, which is it have 9.29 until 21.78. After that is aluminium oxide. So it has 3.37 until 19.13. Next is the titanium dioxide. It have 0.04 until 4.62. And the last one is loose on elections. It have 55.4 until 83.4. So next, it for the found dry sand, it have physical properties. So the first one is specific gravity. It has 2.39. After that, unit weight in kilogram per meter cube. It has 2,590. And the SSD absorption in percent, it have 0.45% and 0.45%. And next is coefficient of permeability. It has 0, the power of the negative 3, or the power of negative cube. So next, so for the discussion, from the result, we can see the all 6 materials have their benefit for producing a green concrete. For wood ash, it has a good physical properties that we can see it from the cement activity index. It's from around 49 until 90, which means that the combination of cement and wood ash or fly ash is good. Besides, the blended cement also shows it's on the material that can reduce environmental issue. Next, for the post-consumer glass, it is very useful for the form on one product like concrete, where it really helps in make the concrete more durable. Other than that, the form dry slag and actually is the and sand actually is the same kind of material that is used for construction site nowadays, but the product actually is landfill. Last but not least, the pulp and paper mill residual solid, where the chemical properties really give advantages to the concrete mixture, where it can produce the structural grade of concrete.
First of all, the result and discussion for the composition of recycled aggregate, which is we mark it as the RA. The result and discussion of this is the commercial grade recycled aggregate of 0 until 4 mm, consisting of 100% mixed truffle aggregate, show a high variability in composition, which is the 100%, we use 100% of mixed rubber aggregate, and it shows the high variability in composition. Then the content of brick and tiles in the sample varied between 10% and 25%, the content of concrete between approximately 25% and 50%. This variability is present as well in recycled aggregate of 5 to 8 mm. As a result, for instance, recycled aggregate of 7 mm contain a higher amount of crushed concrete in petrographic terms than recycled aggregates of 5 mm, despite the much higher percentage of recycled concrete aggregate in recycled aggregate of 5 mm. And this is the result in discussion for the particle density, water absorption, and volume of void. As you can see, this is the graph of the water absorption in percent and versus the particle density, which is a kilogram per meter cube. As you can see, it decreased by a second aggregate from 0, a second aggregate 1, 1, 2, 3, and until second recycled aggregate 8. From the test and from the table, from the graph shown previous, it shows higher density and lower absorption, but there are only one small difference between the aggregate with respect to loose bulk density and volume of voids. A high proportion of bricks, tiles, and concrete causes a low particle density and higher water absorption due to the high porosity of this material. This is explained which is the high proportion, which is high proportion of brick, tile, and concrete that will drain to a low particle density and the higher water absorption. And then the volume of voids of recycled aggregate is higher than the one of primary natural aggregate. We label it as PNA, that is in the range of 24 to 29% for a similar sieve curve. Then the higher values for crushed aggregates are due to the shape and roughness of the particles. It is needed to produce a concrete with a good workability. Next is the result and discussion for the properties of fresh concrete. For the fresh concrete, the mixtures of recycled concrete of 5 mm until 8 mm shows slightly lower flow values while the void content remain constant. The high porosity of the recycled aggregate has a considerable influence on the concrete production. In comparison to natural aggregates, the water demand to reach a good workability is increased. Increase result in a significantly higher the total of water cement ratio. The results obtained show that the water demand increased with increasing content of bricks, tiles and concrete in the aggregate due to the high porosity present in these materials, which is the result of the water demand increase with the increasing of brick, tile, and also concrete. Next is the properties of hardened clay. This is the properties of the mixture test, and this is the properties of the various mixture table, as you can see here. And this is also the summary of the experimental result. Then we go to the explanation. The compressive strength. The compressive strength result is it is decreased with increasing of water content. However, compared with conventional concrete, the values are higher at a corresponding total water cement ratio, which is the compressive strength decrease with increasing water content. It compared to the CC, the value are higher at the corresponding total water cement ratio. The water absorbed by the aggregates is not available for cement hydration, causing relatively dense space in relation to the water-cement ratio present. Then for the E modulus, the bending tensile strength increase with increasing compressive strength. There is no significant difference in the relation between the compressive strength and bending tensile strength of recycled concrete in comparison with conventional concrete, which is CC, based on the range of conventional concrete given. A qualitative analysis of the fracture zone of the tested specimen shows that the majority of bricks and tile particles present are fractured. Their strength is lower than that of the hardened paste, or they even represent a weak point mechanically. Then the results discussion for the drying shrinkage, creep, oxygen permeability, and chloride conductivity. Due to the water absorbed during mixing, these particles are able to swell during the first few days after production, and concrete with a content of bricks of 70% can be expanded. The recycled concrete shows a higher shrinkage than conventional concrete at higher age due to its high volume of paste and higher water content. In addition, the creep rates of mixtures recycled concrete of 1 mm to 4 mm are significantly higher than the recycled concrete, which is of 5 mm to 8 mm. The amount of low-strength particles in the aggregate, like bricks, tiles, increase creep. The recycled concrete containing only 25% recycled aggregate that shows the lowest chloride conductivity. It means that the only 25% of recycled aggregate shows proven the lowest chloride conductivity, and it tends to increase with increasing content of porous aggregate. Recycled aggregate increase the chloride conductivity due to their high porosity. Oxygen permeability increase with increasing compressive strength, and that on the other side, oxygen permeability decrease with an increasing proportion of recycled aggregate in the concrete. Thus, the recycled concrete of 5 mm containing the highest amount of recycled aggregate, which is 90%, that exhibits the lowest oxygen permeability. Okay, this is the result in the discussion. This is the graph of the load versus displacement in the meter, and this is shown the graph for recycled concrete 5 mm, recycled concrete 6 mm, and also the conventional concrete. And beside it, it has the load graph versus the strain graph in percentage, which is it graph is for the this is the recycled concrete of 5 mm, recycled concrete of 6 mm, and also the conventional concrete. This is the graph shown of the graph load versus strain.
So for the critics part, how well the studies address the research questions. Were there any limitations? So yes, the study is able to address the research questions through the explanations and the provided table showing the type of the agro waste and prototype for the production of the biobrick. Secondly, how accurate were the results? Are any of the results convincing? So yes, the result shown in the provided table is convincing since it states the facts by giving example of one of the country that facing the same issues. Nevertheless, the result is not that accurate since there is no results proving the strength of the biobricks. So here, for the articles, we can see that they are making some comparison between the burnt clay bricks and also the bio bricks, but there is no facts that uh, or testing session that will prove the bio bricks is better than the burnt clay bricks. Second and third, what aspect of the research works were unclear? How do the studies going to contribute to the development of the future sustainable products? So one of the unclear words in this research is about the facts about the biobricks testing. The article just provides the theoretical results without the testing to the sustainable materials, which is the biobricks. So the production of the biobricks using the agro waste is seen to contribute to the development of future sustainable products due to the benefits and also the advantage of the biobricks production. So that's all for the critics part.
Okay, next, I have uh, some what to say, which is I want to critique this article. So, for the first question, how will the studies address the research question? Were there any limitation? Okay, for me, actually by the explanation, the studies can be able to address the research question, and it also provides some accessible information where I can get new knowledge about it. And for the next question is how accurate were the result? Are any of the result convincing? Um, so for me, it provided for the result it provided actually, but not for all the materials, such as for the first consumer glass and blended cement and also the farm drying slag. There is no proper result that I can do my research, and I can say that the result also not too accurate, which shows no evidence for experiment being performed on the concrete. And for the last question, what aspects of the research work were unclear? How do the studies going to the contribute to development of future sustainable? Okay, for me, at the applications of fundraise slate, where it didn't come out with enough information. There's no any experiments shown for each recycled material on the concrete, and so that's why there's no procedure or any other method that they use it for the concrete. And the production of greener concrete by using recycled material is contribute to development of future sustainable product because of its advantages for construction and environment also.
The critics of this article is first the question how well the studies address the research questions. Were there any limitations? Uh, my answer is the study are being able to reach the research question as with the methods and finding provided. And also there are many types of tests being provided to study this of recycled concrete material and mixed rubber material can be used as a sustainable product in concrete. Second question is how accurate were the results? Are any of the results convincing? Yes, the results obtained shown in the table are overall convinced with the test conduct, but there are several tests that not accurate as not all of the table provided were clear, and also the method used is not too very clear, it's slightly not too clear, and it's been so hard to understand the method because it's not clear. And last but not least, the question is what aspects of the research works were unclear. How do the studies going to contribute to development of future sustainable product? The answer is one of the unclear aspects in several of method is it is not clear on in the article and only provides as example a code number for conducted the method, which is the as example the dry test based on the NS2011 or something like that, and it's being so hard to understand the code number, so that it was not very unclear to understand on what the specific method that being used in this article. And next, the production of the recycled concrete aggregate and mixed concrete aggregate seem to be suitable to be used in the production of concrete, as it is strong enough to differ more strongly from concrete with natural aggregates than those of recycled concrete produced with concrete, with the benefit of itself to the construction and also the environmental.
Conclusion. So for nowadays, we know that the world is burdened with various wastes, including the agro waste that will cause various pollution, especially if the main option for disposing of the waste is through incineration method. Incineration means burning. So on the other hand, the construction industry is currently growing rapidly. In line with these developments, this industry demands a very high response towards the raw material, especially bricks, for the construction purpose. Although it is good for the development and improvement of the country's economy, but we must bear in mind that the increase of production of construction's raw material will lead to increment of the greenhouse effect to the earth due to the release of carbon dioxide to the atmosphere. Therefore, the biobricks made of typical agro waste seem to have much better net carbon footprint. They have a less environmental footprint than traditional building material such as bricks and concrete, while also being relatively inexpensive and simple to use. As a result, transforming agro waste into biobricks could assist address both the construction industry to form materials and the agro waste also disposed in a proper and beneficially. So that's all for the biobricks. So in conclusion, in a nutshell, I'm totally agree for the production of biobricks since it will give more benefits to the earth, especially for the consumer and for the construction industry. So that's all. Thank you.
So next, the conclusion is The recycled materials that have been mentioned before are the materials that can save Earth from the problems regarding to the environmental. Recycling is the one of the way to reduce disposal costs, conserve natural resource, and provide technical and economic benefit. This is what we call as the sustainability, where it can eliminate the waste and take life cycle responsibility.
The density of recycled aggregate is considerably lower and water absorption is higher than those of natural sand and gravel. A relatively high amount of water is needed in concrete to reach a good workability due to the high water absorption of recycled aggregate. If the aggregate is not recycled, furthermore, the Eurocode 2 gives a conservative prediction for the shallow resistance of the beams made with 90% of recycled concrete aggregate and also 60% mixed ruffled aggregate respectively. The use of recycled aggregate of 5 mm and recycled aggregate of 6 mm show no significant influence on the shear resistance of T-beams. Thus, the properties of recycled concrete, which is RC produced with mixed rubble aggregate MRA, tend to differ more strongly from concrete with natural aggregates than those to recycled concrete produced with concrete RC-C, which is the recycled concrete produced with concrete RC-C. Therefore, it is preferable to use this type of recycled concrete in elements which increase shrinkage and creep are not problematic. Overall, the use of sustainable material is important to lead to far less waste than other types of material, such as plastics, meaning less landfill waste, less energy consumption, and less impact on the environment as a whole, and also less construction waste will produce. Thus, it also saves the cost, so it will save money, save animals from being contaminated with waste from construction site, as well as be able to take care of this environmental for a long time.
So this is where article that we found as our reference. So everyone can click here, or you can type the title on the Google, so you can find it. So that's all from us. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.